glottis are great. That is, the vocal folds move a rather large distance away from the midline. The glottis opens rather widely each time. Because of the thickness of the folds, the glottis closes firmly and remains closed an appreciable time in each vibration, so that air pressure builds up below and fairly bursts out. Each puff of air opens the glottis almost explosively. The air presses them apart at the bottom first and bubbles through to the top. The glottis also closes at the bottom first. This is called a vertical phase difference. All of these characteristics make chest voice suitable for low frequencies, comparatively loud, and rich in harmonic partials. Let us listen to it again. We shall vary one factor at a time, keeping the others constant. First, only the interarytenoid muscles contract. We observe no vibration, but when we suddenly apply a spurt of air, it will start. Now let us contract only the lateral cricoarytenoid muscles. The tone is rather breathy because air is escaping between the arytenoids. The action of the interarytenoid muscles will close this chink. With the increased efficiency of the glottis, we can reduce the flow of air. Now, with the interarytenoids firmly contracted, let us increase medial compression, other factors constant. Now let us reduce medial compression and then increase airflow, other factors constant. Now let us reduce airflow and then increase longitudinal tension, other factors constant. We observe that intensifying any one factor while keeping the others constant causes the pitch to go up and the loudness to increase. However, unless medial compression increases at the same time, it is impossible to increase longitudinal tension very greatly in chest voice. Let us keep in mind the thickness of the vocal folds. We have been observing their behavior when they are like this. But now let us apply longitudinal tension. The vocal folds become thin and tense. The sound they will produce is a falsetto tone. At large degrees of longitudinal tension, we can expect small amplitude of movement. It is difficult to move the vocal ligaments away from the midline. Let us apply adequate medial compression and air and observe the vibration under normal light. This is what the stroboscope shows. It seems to be at the same frequency as chest voice, but this is the effect of the delta F generator. Actually, it is over 2 octaves higher than chest voice. These are the distinguishing characteristics. there must be great longitudinal tension, and with it, medial compression will also be needed. The longitudinal tension will lengthen the vocal folds. Consequently, the vocal ligaments will be tense. Even more tension can be added to register after the ligaments have been stretched to maximum length. The vocal folds, as we have seen, are thin. Because of the great tension, the amplitudes are small. That is, the glottis does not open as widely as in chest voice. Also, the glottis is not firmly closed in each vibration. Often in falsetto, the glottis does not close completely. Because the vocal folds are thin, vertical phase difference is negligible. That is, there is no such thing as the glottis opening at the bottom first and then at the top. Let us listen once more. First, only the interarytenoid muscles contract. We observe no vibration, even if we give a sudden spurt of air. Now let us contract only the lateral cricoarytenoid muscles. Now we add the contraction of the interarytenoid muscles. We observe that for the best falsetto, both contraction of the interarytenoids and medial compression are needed. Now we have only the interarytenoids contracted, and we shall gradually add medial compression until the tone begins and then increases in volume and rises in pitch. Now we reduce medial compression and increase airflow, other factors constant. Now we reduce airflow and, keeping it constant, increase still more the longitudinal tension, which is already great. Between these extreme adjustments, chest and falsetto, we can produce intermediate types of vibration corresponding to intermediate degrees of longitudinal tension. This can be seen in the excised larynx here and, of course, also in the living larynx. Now, with adequate medial compression, let us begin in the upper part of chest voice and increase longitudinal tension. Now we go back down.
Before we observe the living larynx, however, we must familiarize ourselves with some more parts of the larynx. Our study up to this point has concerned itself with the most important structures of phonation: trachea, cricoid, thyroid, cricothyroid muscles, arytenoids, posterior cricoarytenoid